Hey, good morning, everyone. Thanks for joining in today on our webinar for using Signal Pro with next-gen utility communications. Uh, Today, we're going to go over some of the different use cases that existing customers are utilizing within that utility space to plan out for different types of networks. Uh, the webinar will be led today by Brian Jones, who will walk us through. If at any point the in the webinar that you have questions, there is a Q&A button within the Zoom panel that you can submit in a question, and we'll take some time towards the end to answer those, and we'll be watching for those as the webinar goes on. So again, thanks for joining in, and at this point, I'll pass it over to Brian, who will get us going.
Thanks, Rory. To start out with, I wanted to just go ahead and bring up SignalPro and make sure that everybody can see the screen at this resolution. If in the question or comments window, if anybody's having trouble where they can't read the screen or can't see it, please speak up. Sometimes I need to switch around my resolution. As Rory said, we've got a number of use cases to look at here today, and I don't have the prettiest slides in the world, and really I only have a few slides, but I do have a lot of use cases to show you today, and I'm going to kind of cover a lot of ground and just touch on and give an overview of where the features are to address some of these use cases. And I'd like to really open up the invitation to, if you've got a quick question, go ahead and ask that right in the chat during this webinar. But if there's something that needs a little more discussion, or if one of these use cases rings true for you and you'd like more information, or your use cases are a little bit different and you'd like to talk about how to address those, please do reach out to us either through your sales account manager or through the support portal, and let us know what you're doing. We have a lot of conversations with folks in the utility space and see a lot of different product solutions out there on the market, both here in the United States where I am and internationally with our international customers. We see a variety of equipment, and we're seeing it used in a whole variety of different ways. So what I'd like to do today is sort of, again, touch on some feature sets in SignalPro that apply to those use cases and kind of get you thinking maybe about use cases that you might have on your own horizon and how you can address those in the software. So the first sort of area of use cases I wanted to look at today is for distribution communications radios, or in other words, the control radios that go on transmission system, transformers, reclosers, that kind of thing. And I specifically, it doesn't say so, oh, I guess it does say so on the slide. I specifically wanted to call out the GEMDS radios because I think among our SignalPro users, both domestically and internationally, we see those radios the most often in this application. And there are some other things out there, but they operate with a very similar approach. And the main thing that I want to call out about these radios is that in order to reduce latency and ensure the most high reliability connection, most of the GEMDS equipment and other distribution equipment is designed to operate in a point-to-multipoint layout. Or in other words, in a perfect world, every remote out there is going to communicate directly back to its gateway with a single RF link. However, the radios are capable of switching into relay mode. If there is a remote radio that's online and one of its neighbors can't connect directly through the gateway, it'll go ahead and take that traffic and relay it up to the gateway for its neighbor in kind of a store and forward way. And you can have several hops within that relay mode before, in some cases, if you've got long chains of hops, you may need to put sort of a refresher node in there, or gateway. And there are some rules about how the equipment is deployed, and those rules change depending on which particular set of equipment you have. But when we do the planning, if you're only just looking at your planning in a point to multi-point mode, and so let me bring up my SignalPro project here, and I'm going to dig into this project in a little more detail in a moment, because this is actually an LTE project, and this is a point to multi-point study, right, where all we can really see are the RF links back to the single most desired gateway. So for example, if this one's marginal here, I can go into display study results, and I can look at all my different study results or look at that path profile. But it's, and there are even some tools here where I could say, well, what about this device linking to another gateway? If I were to set a focus on another site and say, show me the link to that site, I could evaluate on an individual basis whether a particular remote location has a connection to an alternative gateway. But I don't have any way to just immediately evaluate the end-to-end redundancy of this network when I consider that any of these remote points can also be a relay point. And so, and you notice here, again, this is using RSRP and RSRQ. This is a project I will come back to in a moment, or in a little bit here in this session, to talk about how we would set up LTE or 5G systems if you were going to use LTE for those transmission radios or what have you. But first, let me go ahead and jump to another project. I've got this distribution example here. Yeah, we'll save that. And Rory, if any questions come in on the chat, do feel free to just sort of break in here before I've gotten too far away from the topic.
Yeah, we'll do.
So what I've got here, I've got a much more sparse project than the last one, where this is a completely hypothetical project, of course. I'm not going to get online and show somebody's real actual distribution assets in a public webinar, but I've set this up to be sort of an intentionally problematic area. I chose Bainbridge Island here in Seattle, where I'm located. And this is a really hilly island that has, if we look at the terrain, we've got some hills that sort of run north-south. And I intentionally created sort of fairly sparse remote locations here so that these things can operate in relay mode, but there aren't all that many of them. And I don't have all that many gateways, and the gateways might be sort of far apart. So now, of course, we know we can set these up as a point to multi-point, but in the case where we know that these radios may have to operate in relay mode, and for example, some of our international users, if the territory covered is really huge and there's just no way to have enough gateways to directly serve all of those remote locations, we do see use cases where by necessity, these radios are operating in a relay mode in order to get, sort of one or two, maybe three hops to get down into all the little canyons, or if there's a lot of foliage blockage or that sort of thing. So while the manufacturer may say that these should be a point to multi-point topology, and they operate best in that way, if if the situation calls for it, they can be set up with our mesh module tool. And so in terms of the product mix you'd have to have in order to do this, we would need SignalPro with the mesh network module here. And if this is not something you have in your product right now, if you've only got, SignalPro, bear in mind that let's say you wanted to do a reliability study, do a end-to-end reliability and topology studies for an area, you could always add this module on temporarily to your software to do those studies and save those projects and then archive them. So if this isn't something you do all the time, you can add that on. But so looking at the link lines here, what I've set up when I go into my mesh module, I go into my Mega Mesh Network tool, that I'll talk more about this during this session because this is an extremely powerful tool set. Of course, it originally was designed with AMI, metering infrastructure in mind. And so a lot of people think of this as purely a metering tool and not a distribution tool. But as I'm showing here, when we are using those radios in a relay mode, suddenly these mesh design tools become very, very relevant. And the extra good news is that because you have so many fewer distribution assets than you typically do metering assets, the mesh tools will run really quickly with a typical distribution project. So the overall workflow, and I won't drill into this too deep, but the overall workflow is to set up our different types of equipment. In this case, there's really only one type. It's the radio, whether it's operating in relay or remote mode. And then we import all of those relay or remote locations here, just a simple CSV import. And then I can set up the mesh studies where I choose my propagation model and run the sorting. And then when I do the run mesh studies, here's where it's actually calculating those remotes that can connect directly back to the gateway, they will do so. Those that can't, they have no solid connection back to the gateway, they'll try to hop to their neighbors instead with a shortest hops type of path. And so that'll tell me, and I can run this because it only takes a moment. That'll tell me if I have any devices that are still unconnected. And in this case, I do. And if I drill into that gateway, I can see I've got a couple devices here that are just hard to reach. Maybe there's clutter, maybe they're down in a valley or whatever. And I could, if I need to, then on the fly, place repeaters or evaluate potential repeater locations. I could say, okay, where could I stick in a relay here that would improve my redundancy overall for the network, just moving around. And of course, if I have candidate tower locations, I can snap that on, and these are all my utility poles where I actually could put a relay. So maybe it looked like there was a good intersection there. So maybe that location right there, I would want to go ahead and add in a new relay location to connect up that unconnected device. And this type of planning would just take a really long time if we were looking at this in a purely multi-point and point-to-point type of mode. And I see folks doing that occasionally, just using our regular point-to-point tools on the main map to evaluate, how to get relays of links. And that's fine if you only have a few assets out there, but but gee whiz, if you've got 50 or 60 endpoints, it sure becomes a huge task. So once I've got everything connected, I can then also run this topology report, which will identify places where there is a single point of failure back to the desired gateway. And it will also identify alternate hopping paths back to alternate gateways. So if I'm trying to determine which endpoints have 100% redundancy, meaning that they can communicate with the gateway regardless of whether any of the other relays around them go out or even whether their gateway goes down, this tool will allow me to predict that. And so let me show you the symbols I've set up here. My little yellow sort of hourglass choke point symbol here represents one of those cut nodes or a failure in the redundancy of the hopping path. And then these orange triangles, and I'll make those a little bit bigger. These orange triangles represent endpoints that are vulnerable because they can connect back to their gateway, but there's a point of failure along the chain where if that radio went offline, it would take out this endpoint as well. And so if you, in fact, this new relay that I just added is a perfect example of this. If I drill in here, here, I'm gonna reverse these layers so we can see my symbols a little clearer. This endpoint which was disconnected before is connected now, but it's still vulnerable because that repeater device that I put in, if it went offline, then this guy would have no connection back to the gateway. And in our reporting, we can show the metrics for this. So if I want to show that every relay has multiple gateways it can communicate back to and 0 cut nodes, I can look at my number of servers and number of cuts here. And this says that I have 3 different gateways I could communicate back to for this radio, and that it has 0 cut nodes along its hopping path. And so in that way, we've got users out there that are using the mesh module to design a network that's 100% multi-point, ideally, but in some cases, maybe it's more like 98, 95% multi-point, and there are places where lightweight hopping takes place and relaying takes place. And we can look at those mostly multi-point networks and show that we do have full gateway redundancy and full hopping path redundancy for every one of those radios. So even if we can't avoid the relaying, we can guarantee that we've got redundancy and resiliency in those links. The other thing that I wanted to say about this Mega Mesh tool here has more to do with AMI. So maybe we'll come back to that in a moment. I see something in the Q&A here. The question is there any way to see all possible multi-point to multi-point values in one matrix? For example, I have 10 transmitters and 50 CPEs. I want to see a 10 by 50 matrix of RSRP value. I need to think about that a little bit. Yes, and if you ask that question, this would be a really good one to maybe just put in a support ticket, because or go on to the edx.com support portal and take a look in the knowledge base about per sector studies for running a multi-point per sector study. And I think there's a handy how-to article on how to do exactly that. If not, reach out to us and I can help you accomplish that. So the question essentially is, if I want to see my received signal power or whatever the performance criteria, if I want to see that from every gateway to every remote in a multi-point scenario, can I get that out as a matrix? And again, yes, you can. There's a how-to article on that, I believe. Let me just check in with my slides here. Oh, you know what? There was one other thing I wanted to say about massive multi-point networks, and I'll go ahead and jump to a different project for that. Go ahead and save this. Okay, so here I am back in my, this is a multi-point example, which I'll use to talk both about scaling the multi-point projects and about using our technology module for LTE or NB-IoT or 5G, whatever you may have. If you don't have any of those technology modules, you probably are familiar anyway with the idea of multi-point studies, which this is a better way to look at a fixed point to multi-point type of scenario than, for example, of course, I can always run area coverage heat maps, but those area coverage heat maps are doing the path profile only to a sort of grid cell center. And so you can't have different heights of antenna for the different fixed subscribers, and we're not doing a real precise path profile right to that fixed subscriber location. So if we're doing multi-point, we would go in here and set up different types of CPE. And you can see in here, I've set up just one CPE type for a switcher recloser radio. And if I wanted to, this part is important for the multi-point studies as well. I can have heterogeneous radio types within the multi-point study. So if you've got different radios or different antenna configurations for the radio, you can set that up here. And then once I have these types, I can, of course, import all those CPE locations through the spreadsheet editor with a type associated with them. And that's what I've done here to get my CPE customer terminal layer. And then I set up multi-point studies for each of these different performance criteria. And if you don't have any modules, if you have SignalPro only, then of course you can run multi-point studies, but you only get the ones in this basic group. So I can run my full channel receive power, or I can just look at path loss or shadowing or what have you. If I want to use LTE or NB-IoT or 5G, those have different performance criteria that we typically look at, and we want to run different studies for those. So we want to add on the module, but then how to apply those settings to your project is kind of the thing I want to go over real quickly here. So here, let me jump to my slide again. I've got the bullet points on this. Okay, so the steps we want to go through here are to first set up the base station template. So my sector, transmitter, and receiver parameters to get all the link budget details. I set those up. I also set up my CPE or my mobile unit if I'm going to do area studies. And then we want to set the system type for the sector template or any sectors we have in the project. And we can do that right here under system name or type. I would just go and select the appropriate one. And once I've chosen that system type, I want to go up to the network design analysis menu, go to the appropriate module, and go to system details and service area. And now if you're just only doing one band, one LTE band, for example, then it's quite simple. You can select your band number from the system profile, set your subcarrier spacing and your bandwidth, and then this channel plan template file, this is a simple text file that defines what spectrum you have available to you. And you can create these under Utilities, Create, Edit, Channel Plan Template. And there's, by the way, there's a quick how-to in setting this stuff up in our knowledge base on this as well. So if you want something to review when you come back to this, you can take a look in the knowledge base for that article as well. But so with utility radios, though, very often the basic 3GPP standard for LTE, for like mobile LTE, may not be exactly how your utility LTE products are configured. In some cases, utility products, in order to guarantee high reliability, they will turn off some of the highest data rate coding levels. And so, you know, maybe it won't do 64 QAM as a coding scheme, but that means that the lower coding schemes it does use will be extremely high reliability, and it won't be switching between coding schemes. And so a really frequent question we get is, how do I set that up in my project? And what I'd like to do here is go to the RAN node template. So if I go to Network Design, LTE networks, and then RAN import. So if I'm using LTE, it's going to, by default, just use the standard RAN settings from the standard. But if I go into here and just click on Open Template, you can open up another copy, or a default copy, I should say, of what those RAN settings look like. Oh, I need to resize this. I can't disentangle it from my Zoom controls. There we go. So this RAN spreadsheet, you'll notice there's several tabs along the bottom. And what we can do with this is, if I go over to the CQI tab, and make this a little bit wider still, I can go in here and reconfigure the CQI scheme. And now, normally, my modulation efficiency and SINAR numbers, I'm not going to change those because those are from the standard and they're just how the equipment works. But I might take a bunch of these coding rates and just set them to false, so that when the studies run, it will max out at this 16 QAM. And that'll give me a really high reliability, but it'll report a little bit lower data rate. And that, again, on any kind of mission critical radio, whether we're talking about utilities or public safety or military, very often LTE or 5G radios might have some of these highest order coding levels shut off in their configuration. And notice I would want to do that on both the downlink and the uplink. And the other thing that might change sometimes is the frame configuration. You can see by default here, my slot configurations, of course, the D stands for downlink, and the up stands for uplink, and the G stands for guard band. And according to the standard, there's a bunch of different configurations that are allowable for this. But for example, if I needed a more balanced configuration, I could remove some of those downlink slots and add a couple uplink slots as well instead. And of course, this is customizable on most of your equipment. And in a utilities sort of use case, very often you've got almost entirely uplink data. And so this slot configuration might be completely reversed. And so what we would do there is we would configure the slot, or set up the frame configuration here, set up our CQI configurations, and basically save a custom version. So when it opens this initial template, you'll have some options set in here by default, and you can go ahead and change those options. And then what I always recommend is to save this into your project folder with that project. And then you can go, and I'm not going to save anything here. We're not going to recalculate stuff anyway. But then you can go and browse to that file and point to it here. And if you have browsed to a RAN template and imported it, you'll want to click this import the first time, then that will overwrite those default standard settings. And you'll be able to then go in here with your technology profiles and see, you know, what bands you set up. And I can also go in on my sectors and see which sectors are assigned which band. This is also how you would configure things if you have more than one chunk of spectrum. So, you know, if you've got some 900 megahertz and you've got some 4 gigahertz or whatever, you can set up both of those technologies within your RAN node spreadsheet. And let me jump back to this real quick. So if I set up here more than one, you can see I've got band 41 in this one, and I've got band 48. If I set up more than one technology, I can then go assign different ones to different tables. And it's just a different one that I had open in the background here. And so you would want to then set up those different technologies and the specifics for them, and then also go and assign for each sector, assign which band it's going to use. And this other spreadsheet we'll get to in a minute. I see something else in the Q&A here.
Yeah. So, go
yeah,
ahead,
go
Brett.
ahead, Roy.
Let's say they're looking to set up different antenna heights for CPEs, and they wanted to know where in the software you'd actually go and do that.
Sure, great question, and a frequently asked one as well. In the antenna type, the antenna height that I set here, this is by default only. When I first import a new CPE of that type, if I don't include an antenna height explicitly, it will default to that height above ground level. However, once I establish those CPE types, if I go to RF systems, spreadsheet editors, and CPE data, I also have this antenna height field here. And you can see this has been populated with just my default 12 meters. But if you import the CPEs initially with this antenna height column, or if I go back, you know, maybe I decide one of these doesn't have good connection and I'm going to put it on a taller pole, I can go in and just manually alter the antenna heights here. And when I recalculate the study, it'll take that into account. So you can have an explicit antenna height for every single remote location. And definitely I recommend doing that, especially if you've got clutter height data, which that's one thing I just wanted to call out for customers that have a lot of tree cover and a lot of, you know, their remotes are right down near the clutter height. The clutter height data, where we have a measured clutter height for every sort of grid cell and can do a really careful path profile, that really does greatly improve the accuracy and the reliability of these calculations. And then the heights, of course, become really critical because they, you know, you've got a really clear model of whether each remote has line of sight. So great question there. And if these things happen to just be on my map, so if I've got a customer terminal this way and I'm saying, oh, this one right here, I just want to change its height, you can always right-click on the CPE. As long as that customer terminal layer is showing, you can right-click on the CPE and go into details and change the antenna height right there in the GUI as well. So let me make sure I'm not skipping anything. Okay, so we talked about how to set up the technology for a for 5G, and you'll notice this is the exact same for LTE, or if you're looking at 5G radios for something, it works the exact same way. Of course, the under the hood numbers for 5G and LTE are going to be different. The allowed bandwidths and data rates and all that kind of thing are different for the two standards. And the same thing goes for NB-IoT. If you're setting up for that technology, and gee whiz, I don't even have that set up in my version yet, but if you're setting up for that technology, it's going to look the exact same way, where you'll have the system details for if you're just doing the standard configuration, which for NB-IoT, I think the standard configuration is going to be a lot more typical. So you'll just go into the system details, choose your system profile, and you're off to the races. The next thing I wanted to go into, let's sort of close out this topic real quickly. In terms of the distribution radios or applying LTE or 5G, are there any questions on this? Any other questions? If so, go ahead and type those into the chat. And I wanted to revisit the mesh module really quickly, just to show a couple other show a couple other features, or talk about a couple other features. And I'm going to go back to this distribution example, even though I want to talk about AMI. The automatic metering infrastructure, AMI, is, where we've got a radio in every single electrical meter. Originally, it was a radio in every single electrical meter, and they could forward traffic through each other to hop back to their gateway, just like I showed in this last example, but with a massively greater number of endpoints out in the field. Every single address has one. And so we have potentially a lot deeper hopping chains. And this technology has been widely built out in the United States, and internationally, it's gained a lot of traction in some countries. Other countries are staying more with a point-to-multipoint configuration. But for AMI mesh, one of the sort of new buzzwords we've been hearing a lot is Mesh 2.0, or in some cases, I've heard it called next-gen mesh, or next-gen AMI, where instead of just only carrying one type of endpoint, and maybe electrical meters, in the first generation of mesh, electrical meters, or sometimes water meters or gas meters would be the actual use case for the end device. But in newer mesh deployments and newer planning, in some cases, they may have heterogeneous radio types. So we may have some meters that are water and gas meters down in a pit, and they're on a battery, so they can't carry the traffic of their neighbors. They can't act as a relay. And the mesh module has been able to support that aspect of Mesh 2.0 for years, actually. If we need to have water and gas meters all alongside our electric meters, what I would do here is establish, first I'd learn to type, and then I would establish link budgets for the electric meters and for the water and gas meters. But over here under the fan out, For the water and gas meters, I would put a 0, which means they can't have any children downstream from them. And I can also set some additional rules for those. And so sometimes these are called leaf nodes, but what we're seeing more and more with newer AMI deployments, and in some cases even smart cities projects where we might have other types of remotes, streetlight sensors, security cameras, all kinds of things. And there has been some interest in the utilities hosting those radio services for the municipality. And so suddenly some of our mesh users might be looking at, okay, but what if I have 15 different remote types for 15 different use cases, and some of them are on different frequency bands, and some of them can only act as leaf nodes and all of that sort of thing. Our mesh tool today can support all of that. We can do multiple frequency bands, and you can set up rules for when a message can hop from one frequency band to the other. In other words, you can have a radio that would forward it from one band to another, or a repeater type. And we can set up a whole host of different endpoint types and which band they're on and which what sort of behavior they have, whether they participate in the mesh or not. And if we have adaptive modulation on the radios, so if we need to know where we have high-speed connectivity versus where we just have low-speed data, we can establish that as well. If I go into my mesh study tool here and go to modulation settings, this looks a little complicated, and we have a whole training on this, but just to sort of plant the seed, I can make my copies of this meters list with different sensitivity thresholds, so that if I need a higher received power to achieve that higher speed, I can put that in as the next sensitivity level, and this will basically run the mesh at each different modulation stage. And I have some rules here for how it does the hopping, whether it's preferring the stronger parent or the lowest hops parent. And you can set some customization around that as well.
Hey,
So
Brian,
all that to say, yeah, go ahead.
on the fan out limit, does the fan out limit all downstream children, or does it only limit the number of meters that can directly connect?
We have a great question, and that's a deep question. The fan out limit here limits all downstream children. There's another limit you can put in if you need to limit the number of direct downstream children. So if the radio's got a limit to its downstream neighbors, just how many it can have in its neighbor list versus a more dynamic routing, that can be controlled here or out in the single router calculation settings here. There is a way, if I check this option on, there's a number to limit the direct children right here. Usually we leave that off because that would be kind of a more custom behavior on the radio. Great question. I have one more thing to one more use case I'd like to chat about if I can. Well, actually two more use cases, but I want to make sure and open it up for any more questions about the mesh module first. The main takeaway here is for Mesh 2.0, if you hear that buzzword coming around and somebody asks, hey, can we do planning for Mesh 2.0? If you've got SignalPro and our mesh module, the answer is yes. And we've got some great knowledge base articles on edx.com. And if you need additional help with that, if you've got a use case and you want to know how to set it up, please do reach out to us. We'd love to hear what you're working with and how we can help you with it. So if there's no other questions on the mesh module, are we good on that, Rory?
Yeah, nothing's come in on that.
Okay, I've got one more cool use case that I want to jump to. Let me go ahead and save this. And this one has to do with stuff that flies. As we all know, stuff that flies is always cool. So the use case that I've got here is with an inspection drone flying out along transmission lines. This is a use case we've heard talked about a little bit and had some questions about. And this kind of, it dovetails in with the LTE, because this is one of the potential ways that a utility might leverage some private LTE spectrum is to be able to backhaul data radios from trucks out in the field. You know, if you send a technician out and they're taking video and stuff on their iPad, or staying in touch with automated inspection drones out that are going to go out along the transmission lines on their own. The important thing, of course, is that if your inspection drone loses its connection to your to its data link, then it's gonna start backtracking and go to where it did have connection, and if it can't complete its route, it's gonna wind up going back home and just landing. So what we did here, I set up a very straightforward, simple use case where I've got a transmission line going up over some hills here, and there's a couple little valleys that we dip down into, as you can see. And I have run this first using a path that stays, you know, at a given level of AGL. So this is tracing fairly high above the ground, but it's tracing right along with the terrain. And in fact, how high did I put this? Okay, I put this at about 8 meters up. So this is about utility pole height, buzzing along at ground level. And if that's what the inspection drone was really going to do, we would drop into some big, you know, I set up just a couple 900 megahertz base stations here, and we would drop into some big holes here. And those holes would be worse if we were using a higher frequency band. And so we wouldn't be able to complete this route with just these 2 access points or base stations here. The route studies, though, and I've set this up as a route study because of course, I'm going to have a very precise flight plan for that drone. And this is something our route studies have done for years because of our you know, military work and public safety work. We can actually set up the route study to not be connected to ground level, much like your transmission lines are not actually tied to the level of the terrain underneath them. So if in this case, I used a route that was just tied to ground level, but if I then want to say, okay, but I've got specific elevations, specific heights that I'm going to have my drone fly to, maybe it's first going to fly up the tower and inspect that tower, and then it's going to follow the height of the actual line and go along taking, you know, photos every so often of the line, or whatever it is you're doing for the inspection. What I can do is open up that route. And in this case, I made just a simple little route here. The BNA format that we use is just a comma delimited list of waypoints. So this is the longitude and latitude of my very first point in the path here. And as I go along, this is for my example here, I basically had it fly up to the height of the highest peak, or just above the highest peak, which is right above this peak here, and stay at that elevation the whole time, just to illustrate the concept. But if you go through and plan waypoints with a given height at each waypoint, It'll of course interpolate between those heights as it goes along the route, just like the drone would. And I can go into my define study route here and tell it to use this LEV route file. And so let me go into my project folder. In order to make my route 2, I just made a copy of route 1, which is the waypoints only. And then I make a copy of that called route2.bna.lev. And the only difference is it's got that extra column on the end, which gives the elevation above mean sea level. And if I then go and point, so I'll browse to my route 2 BNA here, and I'll check this use star.lev route file, and that needs to have the same name as my route. And now, if I rerun this route study, I'll get to see the connectivity at those elevations. And so, you know, if I know that I'm going to get much better coverage up at the height of the lines, I can set my route accordingly and guarantee that I've got coverage at that elevation. In this case, it's whooshed right up to 700 meters at that very first waypoint and maintain that 700 meters all the way along its route. So it's too high to take good pictures of the tower, but you can see how I could then go through and tailor those heights. And this is actually a question I'd like to put out there to the group. If anyone comes into this use case where you're actually doing these drone inspection routes, I'd like to ask if there are additional features here we need for you, like coming up with the minimum height for your drone along that route. Features like this are things we've kind of kicked around. And if anyone has a need for that kind of tool, please do reach out to us. I've got just one last use case to talk about, but I want to open it up on this route study here. Are there any questions on this, Rory?
No, nothing specific has come in on that, no.
Okay. This is something that I've heard from a few different folks. It's on the horizon. Maybe next quarter. Maybe next quarter we'll start looking at the actual workflow for how to do this. So when next quarter becomes now today, please do reach out to us and you know, hopefully this plants the seed for how you can achieve this in the software.
Brian, one question.
Oh, go ahead.
Yeah, one question did just come in on can you use route studies for LTE studies? Or are there any?
Yeah, absolutely. Everything that we said about setting up LTE or 5G or what have you applies to route studies as well. So if I go onto my base stations and set up to use LTE Pro and go and set up my RAN node so that I've specifically got the same frame configuration and the same CQI table that my drone control radios are going to be using, I can run all of those same performance criteria. And including, we can do that for route, or we can do that for multi-point or area basis as well. We don't yet have LTE specific studies for mesh and store and forward type radios. So for those use cases, we're kind of having to translate RSRP to RSSI instead. But if anybody's working on that today, I can help you out with that, with the workaround. And of course, that's on our roadmap to be able to apply whatever technology we want to the mesh tool. The challenge there is that our mesh tool is set up to be massively scalable, and so we have to keep the data lightweight in the mesh tool. But great question. And I don't want to take us over time today. So the last use case that I wanted to talk about was probably a use case that you've all heard me talk about before. The simulcast land mobile radio. Of course, there's plenty of utilities out there that still have traditional DMR land mobile radio, handheld and truck-mounted radios that they're using. EDX has still got the most up-to-date reliability studies for doing simulcast and DMR. And if I've already talked to you about the Monte Carlo, so if you've already heard me drone on about this TSB88 Monte Carlo for simulcast reliability, this is really important to do, especially if you've got an existing radio network and you have some known problem areas. This can really tease out what those problems are, whether they're time delay or something else. So this is kind of, frankly, the old news. We've had these TSB88 studies for a while now, although there have been some recent improvements to them, such as they now support mixes of multicast and simulcast together. So if we need to look at our channel plan and look at TDI from our simulcast groups all in the same picture, we can do that with our TSB88 studies. A couple of our utility folks have reached out about other kinds of mobile radio, maybe higher bands, 4 gigahertz broadband radios, things using LTE or other proprietary schemes. There are a few things out there. And we can support all of that as well, of course. And if you're stepping from traditional VHF, UHF, simulcast, handheld radio up into higher bands, and especially going to apply, broadband, LTE or 5G, to do an overlay for that existing simulcast network or that existing DMR network, there are really some changes I would make to the propagation model and how we're utilizing the clutter potentially. So I guess so that I don't go over time today, what I would say is if you are looking at doing an LTE or a 5G overlay for your mobile communications, and you're coming from the standpoint of having done VHF, UHF, maybe 900 megahertz, please do feel free to go on to the knowledge base and check out the articles, or just send us a note and let us know what you're doing, so that we can help you be successful in sort of changing over your projects and making sure that you've addressed all the important details, because those higher bands, of course, can behave quite differently. And I guess whoops, I don't know if I changed something there. The last thing I wanted to point out about if you are doing a newer technology and using MIMO antennas here, MIMO or SDMA or whatever, bear in mind that these table values, the default gain improvements, are sort of the manufacturer's suggested improvements based on a very high multipath environment. So I would say sort of take these default numbers with a grain of salt. And if you're in a lower multipath environment using MIMO radios, maybe consider reducing these values somewhat, or even trying to measure how many spatial streams you really are getting out in the field. We've got some new features on the roadmap for that as well, coming soon to sort of calculate how many spatial streams you get. But in the meantime, this MIMO table here is really important if you're adding a new technology that uses MIMO to your mobile radio portfolio. Okay, and so I'll sort of gloss over the rest of that by just saying, please do reach out to us if this is a new use case for you. And let me just check and make sure I haven't left anything out, but I think we're out of time anyway. Thank you, everybody, for joining today. I hope some of this was relevant for you, and I also hope we went into enough detail to be useful. If more detail is something that would help you get through a current project, please just let us know. We're happy to help. And that's all I had. Rory, do you have anything to add?
Yeah, just wanted to say thanks everyone for joining and to have a great rest of the day.
Okay, thanks. Have a great day, everyone.